Learn how to write Lewis structures. Here's three molecules: sulfur hexafluoride on the left, ammonia on the right, and ozone on the bottom. And we're going to go over the rules that'll let you come up with these structures. How are you supposed to know, on the left, that the 6 fluorines are bonded to sulfur? On the right, how do you know that hydrogen has a single bond with nitrogen and that there's what appears to be a lone pair of electrons, the 2 dots, on nitrogen? For the bottom one, on ozone, how do you know that there's a double bond and all the electrons distributed the way they are? How are you supposed to figure it out? You follow a set of rules. The rules seem very arbitrary to begin with. As you learn how to do more and more structures, the rules start to make more and more sense. So the way I always think of it is that the rules were designed to funnel you to a certain result. And then, once you get that result, you can say things about your compound, like say the shape of the molecule. You need to memorize these rules. There's just no way around it. When you put the atoms down on your workspace, most of the molecules that we deal with at this level, there's one central atom and a bunch of surrounding atoms. In the case of oxoacids, that's something that's a little different. And if your course looks at some organic molecules, that tends not to be the case. But in general, one central, a bunch of surrounding. Why is hydrogen not the central atom? Well, we'll get to that. I'm not going to worry about electronegativity right now. We'll worry about that later. And then why isn't oxygen the central atom for an oxoacid? We'll get to that later. When you put the electrons in for your structure, you only use valence electrons. So that builds off of what we did in a previous section for electron configurations. And the valence electrons goes off of column number using the A, B columns in the periodic table. And then it's not total number of electrons, but total number of electron pair. So you divide your count by 2. And it's analogous to the idea of atomic orbitals having 2 electrons maximum per orbital. But we're not dealing with atoms anymore. We're dealing with molecules and polyatomic ions. But it's analogous. Well, you have to bond up the surrounding to the central atom. That's kind of makes sense. Then octet rule. What the heck? Octet? 8? 4 pair, 8 electrons? Think of where you've heard 8 before. Okay, well, this rule, really out of place right now. Well, we'll talk about it later. Then you get the octet rule. For this rule, though, there are times when you won't have an octet. There are some molecules where you'll have fewer than 8 electrons, 4 pair around the central. And then there are some where you'll have more than 8. So you have to know when to go against the octet rule. Remember, it's not really a code in that sense. It's more of a guideline. And then you have to check formal charges. So we have to learn what the heck a formal charge is, for one thing. And then you have to know when you use the formal charges to adjust your structure if needed. So memorize these rules. And the only way to get better at Lewis structures is to do a bunch of them. The more you do, the more likely you are to see the patterns.